Good morning, good afternoon, good evening, and welcome back, ladies and gentlemen. Yes, I'm your host for the next 2 hours of radio, right here on Truth Frequency Radio, www.tfrlive.com. We're going out live also on YouTube as well. And if you're on YouTube, you can see I have got our fire back, and our guest is moving about a lot over there. He's making a lot of noise. He's getting anxious in the green room, but we'll get to him in just a moment because I'm really looking forward to tonight's show, ladies and gentlemen. We all know that I love to geek out about space. We also know that I like to talk about aliens and all the good stuff like that. And just recently, I was really, really impressed by an article that I read about some really major news coming from space. And there's been a lot of things happening in space since the start of the year. You know, 2020 has been pretty full on so far for a number of reasons. Even the world of astrophysics as well, there's been a lot going on. And that's why I always appreciate the fact that we get to spend a couple of hours every month with our own astrophysicist. Yes, our toe in mainstream science. Exactly. And that's why we're very, very lucky once a month to be joined by Brendan Drachler. Now, Brendan, for those of you who don't know him, be prepared because when me and him team up, we're like a pair of quantum little particles, and we tend to trigger people along the way. We're entangled, me and Brendan. We know just what buttons to push in people. So stand by if this is your first time. We're a couple of NASA shills as well, for people who don't know. And Brendan, officially, all joking aside, is an astrophysicist at the Rochester Institute of Technology, working to understand how we can better detect the most dense and energetic objects in our universe. And that is, of course, black holes and neutron stars. Now, he's also working to understand the fundamental structure of black holes and how we can learn more about them. Now, Brendan has spoken on topics ranging from our solar system to the nature of dark energy to supernova and many things in between. Now, you can find out a lot more about Brendan over at his own website because on top of everything that I've been talking about there, you know, how he manages to get this the State of the Universe podcast, show after show after show, with all these big names from the world of science. It's beyond me, but he does. So please check that out at thisstateoftheuniverse.com. And he's here, he's with us, we're live, and I'm looking forward to what is going to be another good show with our good friend Brendan. How you doing, man? Yeah, well, you're almost like my anchor point. It keeps me in the realms of logic and reason because without people like you, Brendan, there would be a tendency for a character like me to veer in towards the more fantastical and conspiratorial of topics anytime I look at anything. So having somebody that I would regard as in the world of mainstream academia, it's a blessing for me, my friend. And of course, I'm learning all the time. and I learn a lot from you. And because I look at a lot of space stories, sure, it's interesting. And I can get the general gist of what's going on. But then to have somebody like you coming in here to explain some of the finer details, things that maybe myself and the listeners would never have thought about, I think it all comes together to make a really, really good combination. And what better time to have you on the show when we've just had news about the most mysterious, in my opinion anyway, the most intriguing of fast radio bursts coming from a galaxy far, far away. So is this the first contact that I've been waiting for, Brendan? Dang, dang, dude, dang. You don't like that word. You don't like being mainstream. You're like the bad boy of science, are you? Yeah, true. Okay, now hang on, Brendan. Hang on, Brendan. Give me 2 seconds. I just need to do something here. Um, there we go. There we go. So
Are we good?
yes. You were about to take me on with this kind of you're not too happy with the mainstream thing, right? Because that kind of has connotations of mainstream media, and I get where you're coming from there.
Yeah.
And now you've noticed this thing with the sun moving through the sky. Talk to me, man.
Oh no, I was saying that every February when I come on the show and every October when I come on the show, I force myself to be blinded for you, Kev, because my studio sits in a spot where between the hours of 5 and 7 every February, every October, the sun comes through this little crack in the shades and it shines right where my face is. And I deal with that for you, Kev.
You see, this is why you go through that pain just for the Kev Baker show and the audience out there.
I do.
You see, that is what I'm talking about. You go
Yeah.
the extra
Now-
yard, my friend.
Now, mainstream academia. I wish, Kev, that I could do science and not be an academic. And you can. You can do that. But you're generally not going to be able to solve the problems that you're interested in solving. You're going to be working on a more industrial problem, which is fine. And I'll probably end up doing that sometime in my career. It's fine. As a scientist, you should generally just be happy solving problems. That's something I found about myself. I don't really care about specific problems. Astronomy is interesting. Obviously, it's why I'm an astrophysicist, but I'm just interested in solving problems. So as soon as I can get out of the academic culture, Kev, I'm racing out of there for you.
Well, I look forward to that. And you're almost going to be like our bad boy in science. Now I've got a new opinion of you altogether. It's a good light that you've cast yourself in here, and it's definitely going to win a lot of fans on the Kev Baker show. Before we get into the fast radio bursts, I was saying in introduction, we do tend to trigger people along the way. And I think me and you, we've got a boisterous kind of element to us, Brendan. And I think we enjoy triggering people, not because we're nasty, but because it's a really effective way of shaking people out of their kind of comfort zone, out of their normalcy bias. And maybe we force people to look at things in a new light. Now, whether they agree with us after that, that's entirely up to them. I think that can only be a good thing, Brendan.
Yeah, some people mistake the way I talk for me like getting fired up or angry sometimes, because I can do this this voice that I have when I'm talking where it seems I don't even know how to explain it, but when you grow up in the tri-state area, which is in the US, which is where I grew up, and maybe it's very similar where you are, the way in which you communicate with people is by making fun of them.
Yeah.
And you're not making fun of them to hurt them. You're making fun of them because that's how you bond and you expect them to make fun back. You have this mutual agreement that you're going to make fun of one another, and that's how you become friends and that's how you bond. And I use that same way of making fun of people and things to learn about other things. That's how I learn about cultures. I make fun of my Indian friends to learn about India. My Indian friends make fun of me to learn about American culture. That's how they do it, and it works. It's very great. And it's weird now all of a sudden that I encounter people who don't honestly, people who are afraid of being triggered, quote unquote triggered, I'm convinced those people don't actually want to learn about the world. They don't actually want to open up their horizons. They don't want to learn new shit. They just want to continue knowing the same stuff that they knew all along. Or if they're going to assimilate more information, learn new stuff, they want it to be stuff that they expect to learn, stuff that falls into their little circle of indoctrination. It's very weird. I don't get it.
No, I don't get it either, but we will persevere, and hopefully, sometime real soon, all this wokeness and all this triggeredness that's out there, it will just be a figment of our imagination, a distant memory, a time that we look back on and go, wow, how could we have slipped down that stupid? But anyway, moving into some of the topics that we've got for tonight, because you have lined up a lot of stuff for us to talk about. And ever since I've seen this story coming out, I've been telling people that I can't wait to speak to you about it. Not that you're going to be able to give me all of the answers, but to get your qualified opinion and to find out what people around you are saying about the fast radio bursts. We've spoke about these before. And then I get a story where literally, Brendan, I was sitting on the edge of my chair reading it because it's talking about this signal that pulses twice an hour, every hour for 4 days, and then disappears, only to come back 12 days later and start the same thing again. Now, I'll give it over to you now. Talk to us about what these fast radio bursts are all about and why this one is really intriguing.
I think it's 16 days is the period. And it's incredibly interesting. In fact, now that I've transitioned into working in sort of a new field, which we talked about last time, working with a lot of radio telescopes, radio data, pulsars, things of the like, I actually am quite close to some of the people in the FRB world, and I'm going to try to get some of the people on that paper that you're talking about who found that 16-day signal onto my show, so people can come check that out in maybe the next couple months to talk about that more in depth. But no, it's an incredibly interesting find. See, FRBs are real. We were talking about this before the show, Kev. FRBs, for people who don't know, it's a huge packet of energy released from something, and it's in the radio. And the first one was ever detected when people were looking at pulsars. So pulsars are these neutron stars that spin, and they emit radio waves in a very, very periodic fashion. You have a neutron star with a magnetic field. It's spinning, and it's emitting radio waves like a lighthouse. Every time it spins, it's emitting radio waves. They're very, very precise clocks. They spin at approximately the exact same rate always. Now, there's some weird, quirky stuff that goes on with them. But the point is, people were looking at these old pulsar data. In fact, a guy by the name of Duncan Lorimer and his group were, and I had him on the show a couple times. People wouldn't listen to that. Plugging it again. I had him on, and they're looking at this old pulsar data, and they see something weird. And the weird thing they found was like a huge glitch, a huge jump in energy on their time of arrival charts. So they're looking at charts, and it says pulsar here, pulsar here, pulsar here. Whoop, huge spike. And that's an FRB. It was the first ever FRB detected. That was back in 2007, I believe. 2009, 2000, sometime back then when we were younger. Then they found another one. And so we had two. They were mysterious. Everyone's like, aliens? Could be aliens. Now at this point, we found 1,000 of them. The Chime radio telescope, which we talked about before, has found many, many of them. But we were talking about this, Kev. This has made the problem both less interesting and more interesting in certain ways for me. The less interesting part is that obviously now we have a ton of them. So are they aliens coming from every single part of the sky, somehow emitting very similar signatures? Probably not, unless somehow aliens have devised some way to jump across the universe, and every time they use their supersonic spaceship to jump to different parts of the universe.
They're all using the same cell phone network.
Yeah, doubtful. Okay, so so the alien aspect of it has gotten less appealing. But what's more appealing is that now we have 1,000 of them, and they're behaving in weird, different ways. So some of them only blink once, and then we never see them again. Some of them are repeaters. They repeat. They don't seem to repeat with a frequency, with a period. They don't seem to repeat at any fixed rate. They just blip, 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 and there's no seeming period there. And we can localize some of those, and they're not in very interesting places. Like we found some of them in the outskirts of galaxies. So that's interesting in and of itself because they're in the outskirt of a galaxy. If they were near the center of a galaxy, That would be really interesting because then we would start to associate it with the supermassive black hole.
Yeah.
But we're not doing that because we're not finding them there. We're finding them in arbitrary parts of galaxies. So something normal, so to speak, has to be causing them. Now, this finding is super interesting because now it shows a fast radio burst occurring with a period. That opens up the problem to a whole array of potential solutions.
Now, and what does it suggest to you, or what does it open up the potentials? What does it suggest to?
Yeah, so the thing the most interesting thing is the thing it rules out. So every time now the electromagnetic spectrum spans from gamma rays, X-rays, ultraviolet, visible light, infrared, radio waves, microwaves, etc. Not necessarily in that order. Radio waves are at the end, microwaves are before them. Anyway, I digress. We've seen things before, like gamma ray bursts, okay, where we know that this is caused by some catastrophic event. Something catastrophic is happening, and the same thing happens in the visible when we see a supernova. We see a large excess of visible light, and it decays very quickly. So we see like a burst of visible light. We can see gamma ray bursts, which are a burst of gamma rays. We can see all of these things. And so when we saw a fast radio burst for the first time, we just assumed that it was some catastrophic event. We assumed that something was blowing up or something very energetic was happening, and it was emitting these radio waves, and that's why we only saw it go off one time, because it died. Whatever the thing was that caused it had died, like a supernova, like a neutron star that merges with another one and causes a gamma ray burst. That's what we thought. We thought something catastrophic must be happening. A star must be blowing up or eating another star, or a black hole must be feeding, or this or that. There was all these ideas, but all of them were catastrophic ideas. Something crazy was happening, releasing a ton of energy. Now, once we started seeing periodic radio bursts, or not periodic, rather, repeating bursts, so the same burst that happened multiple times, we started to change our ideas a little bit. Some people started to say, okay, it can't be catastrophic, because if it's catastrophic, it wouldn't happen multiple times. You don't see a supernova blow up twice. That's not something you see. It goes off once, and that's it. Okay? So if we're seeing periodic bursts, that implies something really fascinating. That implies that whatever's causing the fast radio burst, the little blip, is not a catastrophic blow up, a supernova type event. It's something that's maybe more periodic, more regular.
Now, could it be, Brendan, something that is continuously pumping out that energy, but we pick up a kind of gap in between because maybe objects coming in between us and the signal? Is that a potential at all?
That's probably not the case. That's very unlikely. And the reason that's very unlikely is because let's imagine that happened once, okay? Yeah. What is the possibility that that could happen at a periodicity of 16 times, yeah, or every 16 days for, I think the observations were 400 days straight? Yeah. The likelihood of that happening are very small. Okay. Now, people have said stuff similar to this, Kev, where they said, well, maybe it's some neutron star doing some weird lensing effect. So, you can look up radio galaxies quickly on Google Images for me, Kev. This is a interesting. So if you go to images, yeah. So the radio galaxies are these galaxies which spew out these giant jets of radio radiation, and what you're seeing there is those little nodes off to the side of the galaxy. If you click on that first one on the top left.
Hang on, and there we go.
Yeah, this one. The reason you're actually able to see that emission is because there's radio emission coming from it.
To describe that for radio viewers, think of a point.
Oh, yeah. So it's like a
star
dumbbell,
in the middle,
maybe,
and then like two ends of it just blowing out, gassing out. So if
exactly.
that was rotating, would that explain it?
Yeah, but that thing could never rotate on the period, because that's an entire galaxy.
Yeah.
So what you're seeing there is actually that a supermassive black hole is feeding on material at the center of that galaxy, that little tiny blob in the center, and it is spiraling up hot gas and blowing it out at the axes. So it is blowing it out the top, blowing it out the bottom like a giant funnel. All right? And we see things like this, which are very interesting, but we don't know what is causing the radio emission from fast radio bursts. We simply don't know because we don't know of much things that could be periodic and not catastrophic, or rather the other way around.
What about some kind of alien object that is orbiting and we only face it so often, and that gives it that signal coming for 4 days and then going away again as it orbits back around?
I mean,
I know
sure.
I know I'm stretching it and I'm taking you into the realms where I usually like to bathe.
Yeah. No. That's fine, right? You can think of that. And in fact, if you went to some journals that were talking about this repeating fast radio burst, you'd probably find some astronomers or some astrophysicists who would say the same thing, like, what is it possible for it to be some alien life craft? Or some alien civilization, which is only emitting this thing. I don't think that's the case. And actually, the reason that's the case is because there's a spread in the signal. So if you actually look at the paper, 16 days is not exact. It's not every 16 days on the dot, right? There's some spread in that. And so generally, when we think if you were a civilization trying to contact other civilizations, you would probably want to have the most pristine, perfect signal possible. That's the way in which you would communicate, because you wouldn't want to have a messy signal. Messy signals look like nature. Clean signals look like beings, intelligent beings. Okay. And so if you saw a signal with some spread to it, so it's not every 16 days, it could be 16.5 days, 16.2 days, 17.1 days. I don't know what the error bars are, but I think they're like 1 or 8/10 of a day. So it's like 16.2 days plus or minus 8/10 of a day. That's the actual periodicity. And you can look up the actual number. That might be wrong. It's something like that. It's something similar to that. So let's just suppose you were an alien, Kev, and you wanted to blast off some...
I am. So
yeah, you are an alien. Okay.
Enough.
Yeah. So let's assume that you want to communicate with other aliens, and you have no real way to do it other than to send off signals. And so you want to send off a signal that's going to be human-like. And the way in which you would think to do that, because you're egotistical like all humans, you would think, let's be perfect. Let's be as perfect as possible. Let's, every 16 days, on the nanosecond, we're going to emit radio waves. We're going to just emit a packet of them, and they're going to go out there, and someone's eventually going to say, oh my God, there's this weird star system that's emitting radio waves every 16 days on the nanosecond. What could it be? Let's investigate it. That's probably what you do. What you probably wouldn't do is hire some stupid engineers that were going to release radio waves every 16.5 days or every 16.82 days, and then they're going to miss a day. So then the next one's going to be 17.5 days later, and then they're going to miss, they're going to do it a day beforehand the next time, and it's going to be 15.8 days. You'd probably be better than that.
Maybe. You give me far too much credit at times, Brendan. You really, really do. But we're going to be coming up on the break in just a moment. And these fast radio bursts, not the only interesting thing that's going on in space. And one of the last times myself and Brendan teamed up, we were talking about another interesting thing that may still be going on, may have happened in the past, or something else might be happening to this star Betelgeuse. Or Betelgeuse, depending how you want to pronounce that. And I believe, Brendan, that's the second brightest star in Orion. Would that be right?
In Orion, I think it's the brightest star in Orion. Maybe it's the second brightest.
Yeah, well, I'll have to go
I'm
back.
not sure.
I took it down in
you
my
can
notes
look.
today.
It's on average, it's the 11th brightest star in the sky.
Yeah.
In the northern hemisphere.
You see,
I don't know about
these Russian websites that I go to, that they've probably got it wrong. So yeah, definitely a bright star in Orion. But this is what really, really sparks my imagination when it comes to things in space, because we're watching light from this planet, and this is what the big story is, why it's dimming so much. And then when I was reading up on it today, and myself and Brendan have touched on this in the past, but this is why space, it absolutely blows my mind. Because whatever's happening on Betelgeuse, it happened, or was happening, millions of years ago. And literally, we are looking back in time. And it could be that whatever happened has already happened, like I say, millions of years ago. And this is why, just one reason anyway, why when you start thinking about space and And that expanse out there, it's really quite hard to comprehend and fathom at times. Our brains, as good as they are, it's really hard to picture just those distances, just how vast this universe is. And then even if you do get an inkling as to how vast it is, you know, could we possibly be the only game in town? And that's a rhetorical question, folks. I will let you answer that. And according to your own belief systems, your own ideas, you will all have a unique answer to that question. But in reality, either there is life out there or there's not. So we'll come back after the break. We'll get into Betelgeuse. We'll get into some NASA news about exciting missions that are on the horizon. And also I'll be asking Brendan about the biggest story in the world. Yes, and the reason I'll be bringing that up with an astrophysicist is because in his hometown, well, it just happens to be that there's people under home quarantine. So all that to come after the break right here on the Kev Baker Show with Brendan Drachler. Check out his website, thestateoftheuniverse.com. We'll be right back. Don't go anywhere. There we go, my man. There we go. Yes, we're still on YouTube with all of these absolutely phenomenal people that are watching us right now on YouTube. But tell us, Brendan, what's been happening on the show? What have you got planned? What's happening with the state of the universe, man?
Yeah, so this week, tonight or tomorrow, one of those times, we'll have a new episode up, episode 70, with Dr. Michael Polland. He is the head of the Yellowstone Volcano Observatory. So, for the people listening to your show that think Yellowstone's going to blow up and kill us all, consider listening to that one, and he breaks it down for us.
What do you think of that yourself off the top of your head? I mean, imminent.
What, with Yellowstone?
Yeah. You always hear online it's going to go any day now, but what's your thoughts?
Michael Polland has convinced me otherwise.
That's good. That's good. Nobody wants to see that.
He's an expert. Yeah. He studies Yellowstone in the most interesting of ways, actually, by using gravity. And you'll have to check out the show to learn more about that. But he assures me that the tubes that actually carry magma to the volcano have crystallized to the point where they would be really hard to mobilize enough magma to cause a super eruption.
That's good.
Yeah, so us here in America, we're safe for the time being. Although that could change. That could change.
Yeah, and when we come back after the break, I'll get you to briefly touch on what's happening with that virus in your city. And then we can get into Betelgeuse or Betelgeuse.
Yeah.
How do you pronounce it?
Betelgeuse.
Betelgeuse.
That's what I say.
Yeah.
Can you also keep that radio galaxy picture up? I wanted to touch on something about it that I didn't get to because you had asked a question.
There. We can touch
and I forgot
on it
to
now.
come back.
We can touch on it now because
sure.
we've got the YouTube audience that can see it. There you go.
Right. The reason I brought this up is because what's actually happening here is you're seeing plasma spiral around magnetic fields and be ejected out, these radio waves. And if you were looking down the barrel of this instead of off to the sides, you would see a lot of radio emission coming straight towards you. And so it's possible that you have something similar happening, but on a smaller scale, on the scale of a neutron star. You might have a neutron star with an incredibly high magnetic field, which is doing the same thing where it's periodically, as it spins, emitting beams of radio waves out one of its poles, and those are funneling towards us.
I can picture how that would work. Yeah, I can picture that. Yeah.
Yes, but there's not thousands. There's dozens of ideas about how to solve this fast FRB problem, and making ones that repeat periodically, repeat non-periodically, and don't repeat at all. It makes it very problematic. The question I always ask people in the FRB community, though, is how do you know they don't all repeat? But they just don't repeat on timescales that you've looked at them yet. So imagine an FRB repeats every 2 years. You know, you wouldn't be looking at the same FRB for 2 years if it didn't do anything for a year and a half. You'd be like, okay, this FRB's done. It's not going to do anything else. Let's ignore it now. So that's always my question. My question is, how do you know all FRBs don't repeat? And a lot of the people I ask that question to say, well, we don't. And that's actually something that a lot of us think about is like, do all FRBs repeat but over timescales that are long? And so it's possible, Kev, that all FRBs actually have some repeating behavior.
Wow. That's quite interesting. I never even thought of that. at all. Now we're getting ready to go back to the network. I'm just keeping my eye on the clock here. But folks, thank you all for tuning in. I'll be back tomorrow during the day. Tomorrow we'll have a safe space tomorrow. I've got a lot of funny news to catch up on, so we'll get into that. And then tomorrow night, the Kev Baker show. Well, I'll tell you in a moment. Here we go. Welcome back, ladies and gentlemen. Yes, Brendan Drachler, astrophysicist at the Rochester Institute of Technology. He's here with us. He's also the host of one of the top science podcasts out there. It's called The State of the Universe, and you can find that on iTunes and most platforms where you can find podcasts. Brendan is there. He's on it. You can go to his website, thestateoftheuniverse.com. So during the break, Brendan, we got back to talking about the fast radio bursts. And before we move on, I think it would be good if the audience could hear, what you were sharing with me and the YouTube audience about how potentially all these fast radio bursts act like the one that we're looking at now. Only we haven't looked for it, have we?
So the thing I always bring up when I have FRB scientists on my show, people who study these things, and I've had a few of them. The question I always ask them, the question I'm always interested in is, how do we know they're not all repeating, but we just haven't looked at them long enough to see them repeat? So it's possible, you could imagine, that the one we found that repeats every 16 days might be abnormally short of a timescale. That might be like on the real low end of repeating. And it's possible that the ones we see that only blink once don't actually just blink once. They actually blink more than once. We just haven't looked at them long enough yet to see them blink twice or 3 times or 4 times. And so a lot of people, I think in the early days of FRBs, they had an assumption that FRBs were a one-off event because we never saw them repeat. But now that we found repeaters, and now that we found periodic repeaters, it's important that we go back and we look at some of the things we've written off as catastrophic events, and we look at them longer and for decades. And we will do that. We have telescopes now that will scan the sky constantly looking for FRBs, and we will match up new FRBs with old FRBs, and we will figure out if they're the same object and if they're repeating, over what period will they repeat. And if it turns out that they are objects that repeat, but they only repeat once every, let's say, 2 years, 3 years, that's a really interesting question. What can repeat every 3 years and emit that much energy is a really, really interesting question. And for the people listening on the radio, I brought up the radio galaxies, but I didn't actually get to tell you why I brought up the radio galaxies, because Kev and I got off on a tangent like normal. So the reason I brought up the radio galaxies is because what they actually are doing is shooting particles along magnetic fields at very, very high speeds off their axes. And so people have posed the question, well, can neutron stars do this too? Can neutron stars with really high magnetic fields accelerate particles, radio waves along their axes and essentially shoot off large bursts of radio waves off their poles? And it's possible they can. And if they can, that the frequency at which that happens will likely be correlated with their spin. And some neutron stars spin slowly. Now, they don't spin once every 16 days. We've never found a neutron star that spins that slow. That's really, really slow. But it's a possible avenue of exploration.
Oh, absolutely. And, on the FRBs repeating, all of them act in that way. It's a really interesting thought. And it's going to be interesting to see if they do go back and look at the earlier ones. It would be unsurprising. You'd actually expect them to act the same way if they're the same thing. Or, of course, there could be multiple things going on. Now then, before we get into the next topic tonight, away from the world of astrophysics, and I get it, this is more probably virology, biology type stuff, but the COVID-19, and the only reason I'm bringing this up with you tonight is because you were sharing with me before the show that it's come pretty close to home for you, Brendan, and the town where you live, right?
Yeah, the city I live in. There's 8 people under voluntary quarantine. So I believe that they had come back from China recently, and they have opted into being quarantined. I don't think they were forced to quarantine, because I don't think they were from parts of China that were affected, at least affected badly. So it's this shit always scares me, because Like even swine flu. I don't know if you remember swine flu that good, Kev, but even that scares me.
Yeah, any virus like this at all, you only need to look at history, Brendan. The Spanish flu, things like that.
I know.
And as devastating as that was a world without the global travel that we have today. So, I'm the same as you do. That when it comes to these things, I mean, these literally have the potential. I'm not saying this one, but there's the potential to wipe out a species.
Exactly. And that will happen again. I mean, it just will. Statistically, it will. There will be a virus we're not prepared for, and it will wipe out a large number of human beings and it won't even necessarily be like the case that the virus is bad, because even if you look at the history of plagues, like most of the viruses that killed a lot of humans, it wasn't always that they're bad viruses. Like they're really, really terrible viruses that really kill the humans' insides or anything. It's normally just that the adequate medical care doesn't exist. And you're actually seeing this in China. You're seeing that they're having to build hospitals to house people because even though they may have the technology, they don't have the space. And so medicine will always be in a perpetual state of playing catch up with viruses. It just will. And it opens up the possibility for bad viruses to spring up and kill. But my fear also comes from the fact that I don't trust the Chinese government to actually report factual information.
Yeah.
So for all I know, there could be 1 million people dead, and I'm not saying there is, but I'm saying that's as much as I trust the Chinese government to report information. I mean, they've already shown a disservice to every country on the planet and to their own people. So why would you trust them to report information to you that is accurate?
Yeah, and it really baffles me why you see the World Health Organization and governments around the world applauding the Chinese government for their response. It just baffles me, dude.
I think the applauding of the response is deserved in one way, in the way that and this isn't even necessarily the Chinese government so much as it's other governments, but stopping it, localizing it to China. We've done a pretty good job of doing that, actually. A lot of people are saying, a lot of the people I talk to in this field are saying that realistically this is a Chinese problem, because we've done a real good job of stifling travel to and from that region. I mean, you see a lot of airliners don't fly there now, or they're going to cease flying there soon. You see a lot of countries who are, incubating you upon return. The U.S. is doing that, 14-day quarantines to everyone who returns. So, yeah, maybe not applauding the government is useful, but I think other countries are doing a pretty good job of stifling the spread of this.
That certainly so far bears out in the numbers that we see, because with so many Chinese citizens that traveled around the world for Chinese New Year, yeah, you would expect to see more in other countries. So, yeah. And again, not just the Chinese government. I don't trust the British government to tell us the truth 99% of the time. Any government out there. And
yes, that's true. Yeah.
I just don't trust them at all.
But I particularly don't trust the Chinese government.
No. I'm with
if I had to rank the governments on trustworthiness, I would probably put them towards the end of that list.
Well, I hope this is the only time we have to speak about this, Brendan. And by the time we come back next month, then hopefully it'll still be there. I know it'll still be there next month, don't get me wrong, but hopefully it doesn't become anything more than what it already is.
I mean, I think numbers are skyrocketing now.
Yeah.
I think you're seeing way more infections now than you did, say, a month ago. Yeah, so it's probably not going away, unfortunately, anytime soon.
Yeah, definitely. And something that may or may not have gone away, and this is back in your field of expertise, sir, is Betelgeuse.
Yeah. I wanted to correct you on something I forgot about before the break. Betelgeuse is actually only 700 light years away. So it would have had to it's actually more like 660, I think. So if it blew up in the last 660 years, we wouldn't have seen it yet. But if it blew up 800 years ago, we would already see it.
Yeah, it would have gone. The light would have finished by now. So talk to us what's happening with this thing, because it's just back in the news all the time. Article from Sputnik, is Betelgeuse dying? Now, what was interesting in this article to me, Brendan, was the fact that it brought up, down at the bottom, it mentions that there's, I just find it here, it says that Last year, astrophysicists calculated that if the star does commit suicide, as they call it, Betelgeuse's demise will release more energy in the space of hours than throughout millions of years of its existence. However, in January, astronomers from Louisiana State University in Baton Rouge completed research concluding that Betelgeuse may have actually devoured a smaller stellar companion recently, rejuvenating the star and ensuring its survival for epochs to come. Now, that's obviously highly speculatory. However, talk to us about Betelgeuse, what's happening there. We've spoke about it before, but it's causing a lot of excitement out there, man.
Yeah, I didn't hear about that. The research out of Baton Rouge. I'll have to check it out. I assume what they're looking at is the metallicity. That's what that would be my guess. Is they're looking at the metallicity, and the metallicity is essentially how much. And I'm not saying this is what they are looking at, but this is the way in which I picture them coming to that conclusion. The metallicity is how much of the star is made of heavier metals and not of hydrogen. And if the star is abnormally metal deficient for how old it is, then that you could come to the conclusion that it must have had somehow hydrogen added to it. And the way in which you could add a mass of hydrogen is to devour a companion star. And we do see stars devouring other companion stars frequently enough that it's not an insane idea. So, but again, I don't know how they did the research. I don't know the methodology of the research. I don't even know the research exists. So that'd be my guess, though, on how they would come to such a conclusion. But no, it's a super interesting thing. That's it's like the coronavirus. By the way, what you're calling it by the official name, Kev, that's a bold move.
Yeah, well, because I was reading an article in the UK, because we're very woke and politically correct over here.
Yep. Are people getting offended by the term coronavirus?
We mustn't call it woo flu like I was calling it, because obviously that has negative connotations for anything to do with Wuhan, and we don't want to leave a stigma on China for being the place where this virus was born out of. So we're
I mean, but it was. That's weird.
I know, but
right?
Political correctness and wokeness means that you have to disconnect from reality. You have to get rid of any kind of common sense that you've got, Brendan, and to be more aware of the feelings of the country of China that could be hurt by us, referring to it as coming from there. Yeah.
See, I have no patience for that.
Neither do I. And
Zero.
I'm trying not to get triggered. I'm trying not to fly off the handle. Yeah, there was even people in the UK saying that it was almost racist for us to be talking about banning flights in from Wuhan and things.
I've heard that. I've heard people saying it, I've seen that on Twitter. People saying it's racist for America to incubate people coming from China, and it's very weird.
Yeah, well, I would rather run the risk of triggering the politically correct crowd than, playing Russian roulette or Chinese roulette with a killer virus. I'm just saying.
Yeah, I don't know. Let's put some of these PC people in Wuhan and see if they care about political correctness anymore.
Those are the people that think it's all fake. One of the two.
Yeah.
Or maybe both sets of people we can send there, and they can take care of it. How about that?
Yes.
Yep.
It's like I hope in the future, I would love a reality show where you could take people who denied certain things and expose them to the truth in some way. So, like, I would love if we could take flat earthers and put them on a rocket to space. That would be my they would say the glass is fake. The glass
I
is
was
a
just
screen.
about to say that they would say you've probably tricked them and you've put them in some kind of rocket simulator.
Yeah.
And really they haven't gone anywhere, and it's all like that movie Capricorn 1 where they film touching down on the moon and things.
Mm-hmm. Yeah.
I don't know. There's always a way around these things, Brendan, you see?
There is. It's very weird. Yeah, that's why you shouldn't put much effort into worrying about them, I suppose.
Nah.
It's the same thing with like the PC culture. Like, I'm still not convinced that that's a large enough subset of the population in the real world. It might be on Twitter.
Absolutely.
I don't think it is in the real world.
Oh, in the real world, Brendan, you rarely see anybody that displays this behavior. But then again, these people live their lives online. And they think that Twitter is the real world. And that's why, they need safe spaces and things when they do venture into the real world, and they realize not everybody is as mind controlled and stupid as them.
I love working on a college campus because I see so much of this stuff.
Do they have safe spaces there?
I mean, they might have. I don't think so. They might.
I just picture people your age, like young men and women, sitting with finger paints and Play-Doh and nobody making a noise and somebody rocking, crying in the corner. And it's like something out of One Flew Out of the Cuckoo's Nest, man.
Yeah, you certainly see like these PC people on the campus, and I've heard people have their speech corrected before and shit like that. In fact, I've even been in argument. I like to discuss things with people. So a lot of times at lunch, me and the people I work with will be talking about things that actually matter in the world, like whether there's a patriarchy or not. Okay. And I'm laying out information saying, no, women have an equal chance at opportunity here in America. And they're saying, no. And you'll have people interject themselves in the conversation and try to, bring their wokeness with them. I recently had someone do that with Bernie Sanders to interject themselves in a political conversation we were having to preach to us about the greatness of Bernie Sanders. So it's weird. It's an odd culture to be in, but it's kind of fun. It's kind of interesting.
Yeah, I would imagine a guy like you, and I put you in the same kind of idea as me. We think similar thoughts. We view the world a similar way. But I would imagine it could quite be really amusing to be that type of person in a college campus these days with all that madness going on. I mean, there's always something to laugh at, right?
Yeah, it's fun, and it's fun because almost everyone isn't that way. That's why it's
so
fun.
Encouraging. It's so encouraging to hear, man. It really is.
It's very abnormal, I think, for people to be that way. It's definitely not a norm. It's definitely not a norm for other people to like actively police other people's speech. At least not in my experience. Like that, it's maybe 1 out of 1,000. Like it's rare, but it happens, and almost everyone is in agreement. This is why a lot of times I think that sometimes far left ideas are more dangerous than far right ideas, because everyone knows. Well, I hope everyone knows that a Nazi is a bad thing. Right. So it's almost like if you're talking about, if you're equating far right to neo-Nazism, then we all can agree neo-Nazis are bad people. But people are afraid to agree that people assigning their kids to be gender neutral at the age of 3, not everyone will agree that that's a bad thing. And so therefore it has more of an acceptance in society, and it actually has a negative effect over time, way worse, I would think, than a neo-Nazi, and that's going to get clipped, and someone's going to say that I think transgenders are worse than neo-Nazis, which are,
Hopefully not. Hopefully not. But I get where you're coming from, and when you look at it anyway, the ones that are trying to close down free speech and police everyone else like Nazis, as you stated, they're further on the left-hand side now than they were on the right, so it's a bit of a weird thing, The ones that are fighting the Nazis have almost become like the Nazis. I don't know. It's crazy.
No, it's a weird time to be alive, but I love it. It's fun.
It's a confusing time to be alive.
I love talking to people about all these different ideas. Most people you encounter in the real world are going to be normal thinking people, not Twitter people, and so that's refreshing.
And I think this is a big problem, that some people really do think that what they see online is a representation of the real world. In reality, it just isn't. It's so disconnected from the majority of people that itself encourages me. Because at times, Brendan, you look online and you really do. You can come away with a really grim look on humanity. You can really think, what the hell happened to us? How did we become so stupid as well in so many ways when all of this information is at our fingertips? But then,
no, 100%. And it's this idea of wokeness is undoubtedly a product of being privileged in your life, in terms of you don't have to run from a tiger anymore. So as an example, I don't imagine that people living in the Congo are worrying much about gender neutral bathrooms. That's not a
Exactly.
thought in their head. People in working class America, frankly, don't care much about whether transgender people in prison are allowed to have their sex changes paid for by the federal government. That's not something that they care about because they're worrying about feeding their children. So it's a crazy concept that frankly is like only discussed amongst rich privileged white people. And it's funny how then you have a scenario, and this is going back to what you're saying before, Kev. If you look at the people who actually want PC culture, you can look at these polls done by a variety of different pollsters on every side of the political spectrum, and you'll find that black people, Latino people, Asian people, they are all opposed to PC culture at way higher clips than white people. And white people who are rich tend to be really opposed or really on board with PC culture and opposed to the idea of being able to, freely speak whatever you want to say. And so what happens is you actually have rich white people trying to write the narrative of people who are quote unquote underprivileged, which means what do you have? You are recreating the exact same system that these idiots think they're trying to fight.
Precisely. I seen a video the other day of a couple, and I had no words. It's a couple, and I believe it's New York or somewhere. A white couple, man and woman, and they're actually bending down, kissing the boots.
I saw that, and it was. I
didn't want to bring it up because I honestly thought surely this is parody. But then when I look at everything and put it into context, maybe it's not. But literally, people...
I don't know what was happening in that video. I when I watched that, I was like so utterly confused. Like what am I seeing?
Yeah.
I don't even know.
Is this part of this what they call white guilt because of what's happened in the past with oppression? And listen, what's happened in the past with slavery and stuff like that, or any of these things, it's a bad thing. But it wasn't me and Brendan. It's not our fault. And I'm sure we don't have some kind of bill to pay on the back of it that involves me bending down on the knee in public and actually celebrating kissing somebody's dirty boot.
Yeah, my ancestors were gassed to death in Auschwitz, okay? I don't expect reparations from the Germans.
It's just mind-boggling, dude. I have no idea what is wrong with some people.
Yeah, I don't know, man. It blows my mind. But maybe we should transition back to Betelgeuse.
Before we trigger everyone, Betelgeuse.
Yeah.
Not millions of years, but hundreds of years ago, something could have started happening. Talk to us, man, because I gave you credit for a simulation today, and I found out it wasn't your simulation, but credit to those who made it. So what do you think's going on there, man?
We have many simulations of... Do you want to pull that up, actually? That's an interesting video. You can click in the links I sent you, Kev. Go ahead and just click the second one first.
Yeah, 2 seconds. I'll get it over here, and then I'll pull it over. You talk to us about Betelgeuse, and I'll get that.
Yeah. So we have many simulations of red giant stars, and we know pretty well how they behave. We know what they do. We know how they react. We know how they live their lives. Betelgeuse is a supergiant star, or a red giant star rather, and it goes through its life very quickly. While the sun lasts billions of years, stars like Betelgeuse last millions of years. Because if you want to play this video on the left is fine, Kev. So what you're actually seeing here is how one of these stars would look if you were closer. This is a simulation, a high resolution simulation, which takes into account all the necessary physics, not perfectly all the necessary physics, but a lot of it. This is in general how you would see a star like this. And what you're seeing here is large scale convection. So convection, Kev, is essentially the exact same thing you see when water is boiling. You know, when you boil water and you see the water sort of forming these circular patterns. Yep. So what's actually happening there is the water at the bottom of the pan is getting really hot. It's in contact with the hot burner. And as it gets hot, it comes to the top because it wants to, or it cycles with the cold water. Cold water comes to the bottom, hot water will come to the top. The cold water will get hot, it'll come to the top. The water on top will have cooled, it will go back to the bottom, and you get a circulating pattern of water. And that's it. What you're seeing here is you're seeing large-scale convection, where the hot material further in the star is being circulated out and the colder material is being pulled in, and you're seeing this happen over time, over and over and over. And you can see, and the sun does this too, actually, but it doesn't do it quite on the large scale because the sun is much smaller, and so it is much more tightly compacted than a star that is so big. And if you pull up my Twitter post, Kev, that I was saying, this video I made this morning, I can show you in essence what might be happening. So don't play it quite yet if you want to pause it real quick. So what's really interesting about this video is that we can't see Betelgeuse very well. It's very far away. It's very far away. 700 light years is a far space to image a star. Keep in mind, we'll talk about this later, Kev, we just got to the point where we can image our own star with high precision. So it's really hard to see a star 700 light years away. And I don't know, Kev, are we going to be going to a break here in a second?
Yeah, we've got 2 minutes before we go to the break if you want to cram something else in quickly, man.
Okay. Well, I can try to cram a little bit. Yeah. But we'll talk about our star later, and our star has a similar feature, but we can't see our star very well. We can now. We're getting to the point where we can now, and it's incredible. But we can't see this star well, so we have to look at it really low resolution images. And what I did this morning is I woke up and I thought, what would we actually see? What would convection on a star actually look like from 700 light years away?
And we'll find out more after the break with Brendan Drachler. And we'll stay on science. We'll try and stay on science from now on in. But we'll be back after these short messages. Don't go anywhere. Right, Brendan, if you need to go and get a drink or anything like that, brother, now's the time. If you need the restroom, you know. But yeah, I don't know how we got so... I think we both got triggered by going into wokeness. I think that's why we spent so long on being untriggered.
I'm fine talking about it for 2 hours. I just don't know, like, if the audience expects there to be science, I don't want them to have to hear about Twitter mobs the whole time, you know?
You know, when it comes to the Kev Baker show, I think they know the random workings of my mind well enough. You know, usually I drag guests here, there, everywhere. We go off on tangents and things, so... It's the way this show goes. You know, it's talk radio, it's real people. These are real things we're talking about. And, you know, we don't censor, we don't script the show. And what comes up in conversation, it comes up in conversation. And if it's meant to be spoken about, which that kind of thing definitely is needing to be spoken about, I only see good things from it, Brendan. And if people are triggered by it, go back and listen to it again. And think, what was it that really made you angry about anything we were saying? And maybe then you need to have a good think about that. That's all I would say.
Yeah, that's always the case, actually. When people get upset by something in conversation, it's because somehow their brain has, like, ignored context. I find that a lot, actually. I remember I did an episode with a woman, and we spent a considerable amount of time talking about this idea of women in physics. This idea that for some reason the percentage of women in the faculty positions in physics and astrophysics is lower than that of men, and why that is. And we were not necessarily saying that there's like a patriarchy that exists that's holding women down, but I got a lot of comments that was like saying things like that, like, Brendan, why would you ever say that exists? You know that doesn't, stuff like that. And the entire time I'm thinking, are you listening to context? Because I didn't say that.
Yeah.
I don't know how you heard that, but I didn't say that. And I don't know. There might literally be like troll farms out there who scour YouTube looking for certain keywords in the tags, and then they just post nonsense. That's what I've come to believe after a certain amount of time.
YouTube, Twitter, Facebook. I think, you know, all comment sections, whether it's just AI bots that are out there doing what they do for whatever reason, I have no idea. You know, maybe even just releasing them to get better at learning language and writing prose. I don't know. But yeah, I do think there's a lot of that, Brendan. I do.
Yeah, I don't pay attention to really any comments I get anywhere anymore, unless they're emailed to me, because then those ones actually tend to be useful or constructive or asking a useful question.
Exactly. Exactly. If people want to get a hold with you with something valid and important, You
Mhm.
tend to find they will go beyond the comment section, and that's
Yep.
something, when you're doing the shows like we do, you know, going through every single comment can be very, very time consuming, right? So I mean,
Yeah, I don't get a ton of YouTube comments, but I get a ton of inquiries in other ways, and yeah, it can be overwhelming sometimes.
now when we come back, then we'll get back into where we left off here with your little tweet that you made earlier. And folks, remember, check out Brendan's website, thestateoftheuniverse.com. I'll let the TFR audience know that when we go back after the break. If you see me looking off to the side, I'm watching the network clock. I don't want to miss coming back after the break. So, yeah, another couple of seconds and we'll be going back there. And tomorrow, the Kev Baker show. I need to get myself a cake. It's 6 years old, Brendan. Yeah, 6 years the Kev Baker show has been on TFR. So looking forward to that. Here we go. Back to the network. Welcome back, ladies and gentlemen, and whoever else may be listening out there. Big warm welcome to the second hour of today's show. If you're just tuning in, I've got Brendan Drachler, astrophysicist and podcaster with me. Check out his website, The State of the Universe, at thestateoftheuniverse.com. Now, before we launch back into it, and before I forget, tomorrow on the Kev Baker Show, same time, same place, tfrlive.com, and no doubt I'll be simulcasting. But the show itself turns 6 years old tomorrow. 6 years we've been here on Truth Frequency Radio. I really, really can't believe it. Over 1,250 episodes, and we're still going strong. Hopefully still giving you lots to think about out there. And yeah, let's hope it's the 6th birthday, but not the last on there. Many more to come. Because you know how I feel about Truth Frequency Radio. It is the #1 network, and that's because it's your #1 network, tfrlive.com. A big shout out to Chris and Cherie Geo for showing faith in me back in the day and for putting up with me for nearly 6 years. I tell you, Brendan, that in itself, the network owners, they deserve a medal for tolerating me for 6 years, right?
Yeah, they do. And if they want to get rid of that flat earther stuff and get real science, give them my name.
That's what we'll do. That's what we'll do. But, talking of real science then, let's get back into it because I gave you credit today when I was promoing the show, and I apologize for that because I thought you'd put the full simulation of Betelgeuse together. But obviously been watching that before the break. You kind of built us up before we went to the break. So for anyone new joining us, Brendan, just quickly recap on this tweet that you put out earlier on today.
Yeah, so everyone in the field is trying to come to some conclusion about what could cause Betelgeuse to dim. What could cause it to dim the way it's dimming? I mean, it is dimmed I think it's only 30% as bright as it normally is. So it's really dimming, and I think it's the dimmest in recorded history at this point. Like it's incredibly dim, and it's leading to a lot of people to question what could make it so dim. Could it be blowing up? Blah blah blah. As far as we know, dimming does not precede blowing up. So there's that. But what could cause it to dim is an interesting question. One of the things I always remember seeing is these simulations done of red giant stars, and this is not a simulation of Betelgeuse. It's actually a simulation of a much smaller star. But it's the same idea. It's a red giant star. It heats itself in the same way. It has convection in the same way. And so you have these large convective cells which are constantly cycling back and forth, and taking cool gas to the bottom and taking hot gas to the top where it eventually cools. And you have this cycling. And I was wondering this morning, and this is why I'm an astrophysicist, I suppose, because I'm wondering when I wake up at 7 a.m., I'm thinking, if you took a video of Betelgeuse up close, what would it look like? Well, good thing. That question's already been answered by people who have done simulations. Many people have done these simulations. I didn't do this one, Kevin, and the reason I didn't is because it probably took months to run that simulation on supercomputers. That's a high-resolution simulation, yeah. And I imagine a team of people worked on making it, and it probably took a very long time.
Quite mesmerizing. It's quite mesmerizing when you watch it. I find
it's incredible. Yeah.
almost like
And so I
watching
wondered,
like when you're staring at a fire or something, you just kind of draw into it. You lose
Mhm.
yourself in it, you know?
yes, it's incredibly fascinating.
Yeah.
And yeah, I like it. The comparison to fire is an apt comparison. So I had the question, okay, we don't see the star in that amount of detail. This is what I'm thinking at 7:30 this morning. We don't see it in that amount of detail.
As you do at
So
7:30 in the
yeah,
morning, Brendan, you know?
so yep, it's shower thoughts, right? And so what would it actually look like 700 light years away? And so what I did is very simple. I took the video and I just applied some effects to it that would show it in poor resolution. So if you pull up an actual picture of Betelgeuse to show people what kind of resolution we see it at, and probably one of those articles you have up has the picture in it. There's many of them, many pictures released. You could just type in what's that yellow one you have there? Yellow tab.
There you go.
No, all the way. Yeah, perfect.
There it is.
So that is in January of 2019. If you play that video, it'll probably show you what it looks like in December of 2019. So you can see it gets considerably dimmer. Yep. And so it dimmed a lot over the year. And so my question was, how can we visualize that simulation from the Earth? And so what I did is I applied a blurring effect. And if you play that video, Kev, you can see, and if you just want to skip to like 30 seconds, because this is where I think it's actually really okay. Look at the star on the right now, and you can see how when we view it from the Earth's angle, you can see dimming spots and brighter spots very, very, very apparently.
Yeah.
Okay. And so what we might actually just be seeing is did you see that right there? That was a really important one. If you go back.
So the dimming that we're seeing could actually just be a result of this fluid motion of it.
Exactly. It could be.
Yeah.
It could be. And this has probably been explored by people. People are probably writing. I would imagine someone's probably writing a paper right now to try to answer this question. Obviously, my Twitter post is by no means a scientifically, scientifically minded way of doing this. I would actually have to do calculations. I would have to say how much it's dimming. I would have to try to make a prediction. I would have to try to say, okay, the convective cell is going to be this big. It's going to take up this much light, blah, blah, blah. Someone's probably doing that right now, I imagine. I'm trying to answer that question in a scientific framework. And good, I can't wait to see their result. There are some people who say, well, maybe Betelgeuse has some dust around it, or maybe something happened where instead of just sort of boiling that gas, convecting that gas back and forth, instead something happened where it blew off a lot of gas. And so now what we're seeing is gas out in front of the star that's sort of restricting our view to it. There are many, many possible scenarios. This is just one thing that I thought of this morning that could account for such a thing. Could be right, could be wrong. But what's actually causing the dimming, we still don't know. That's one of the coolest things about it.
No, it's super cool, dude. Anything in space I find really, really fascinating, as you can tell. That's why I like hanging out with you. I think that simulation there, and for people on the radio, I've dropped the link into the chat room at TFR. Check out Brendan on Twitter. You'll be able to see what we're talking about, at Brendan Drachler. And having watched that and listening to you talking about it, I think it would make sense, or it's at least making sense to me, Brendan, that that's what's causing the fluctuation, this dimming effect, as they call it. And if that's the case, whoever does come up with that paper, then, I mean, that's going to be pretty significant, right? Because that's going to tell us a lot about when we're looking at objects in the future, what to expect.
Yeah, it possibly, but one of the cool things about Betelgeuse that other stars don't necessarily share is that it's one of the few stars we can actually see the surface of it. So you saw that image of Betelgeuse. Most stars, when we look at them, they don't look much different than when you go outside and look at them in the sky. We can only really see them as little point sources. We can't make out features on their surface. So Betelgeuse is interesting in that we can actually see a sphere or some spheroidal type object. We can't do that with most stars. So, this isn't necessarily a groundbreaking idea by any means, because there are very few stars we can do that with. I don't know. I hope I'm wrong. I hope it actually is catastrophically exploding somehow, because that would be amazing. We talked about it before, but you're talking about an object that would probably be as bright as the full moon, and you'd be able to see it during the day.
That'll be something to behold. Now, you're talking about the surface of Betelgeuse there. You sent me something else today that really blew me away. And you
Yes,
mentioned
have
it
you
just
seen this?
I hadn't seen this at all. And you mentioned it earlier about how now we're getting really, really detailed kind of images of
Mm-hmm.
what's going on with our own local star. You know, that big sun in the sky, folks. Brendan talked to us about this because I'm going to drop the link at YouTube for people so they can check out, or sorry, not YouTube, over at the Truth Frequency chat room so they can watch this actual video. But yeah, talk to us about what's going on around our sun, because this stuff is mind-blowing.
Yeah, this is really cool. So we haven't been able to do a good job of imaging our own sun, which is something that's really people when I say that to people, they always say, "What? We haven't done a good job of imaging our own sun." I mean, we've done an okay job, but for how close it is, we should really be able to see it much better. One of the problems is it's so bright, right? I mean, why can't your eyeballs look at the sun? Because it's just overwhelmingly bright. And telescopes and detectors have much of the same problem. I mean, they just get overwhelmed with light. So you have to be
Even your
clever in how you
cell
design.
phone, you know, you put your cell phone, you see the big lens flares coming. Just can't handle all
Exactly.
that light.
Yes, exactly. So you have to be clever in engineering a way to image the sun. And the NSF, the National Science Foundation, has finally been able to do such a thing with the Daniel Inouye, I believe it's called, solar telescope on Hawaii. And this is some of its initial observations. So it's going to do much better. And if you pull up I believe I sent you one more link, Kev, about this particular story. Yes, this. So some of these cells that we're seeing are the size of Texas. And they're, this is incredibly high resolution that you can see. And what you're actually seeing here is much of the same sort of convection that we saw in that simulation before, but we're actually able to see it in real time on the surface of the sun with a telescope. That's pretty incredible. If you want to bring us back to that video now and play it. So what you're actually seeing is each of these like little tiles on the floor. I don't know if you did this when you were a kid, Kevin, but when I was a kid and we had a tile floor, or I was near a tile floor, I'd always try to like jump from the green colored tiles to the other green.
Man. I still do it now if nobody's watching.
Oh yeah, I do too. I only stay on the orange ones. That's my move. So anyhow, what you're seeing here is that each of these you could imagine like a little tile, and the black border around is the cool gas that is being pushed down to the bottom, and the middle of the cell is the hot gas that is coming back up to the top. And so each of these cells is cycling hot plasma back and forth deep down into the sun. And it's an incredible telescope to allow us to see this. This is nuts.
That is utterly crazy, and again, very mesmerizing. You can just sit and watch that.
You could.
Yeah. Dang, dude. Exciting times in space then, Brendan. So much going on.
Yeah, I'm gonna try to get someone to talk about this too. Someone that works with this telescope and this data, because this is fascinating. And one of the questions I don't know, and maybe you're thinking, is what good does imaging the sun actually do for you? There is one outstanding problem that I can think of that this will help address, which is that the corona is hotter than the surface. Now that's a real weird. So if you look up the corona of the sun, an image on Google, so people can get an idea of what I'm talking about, just type in corona of the sun. Expert Googler. So you have this hot gas around the sun, and you can see it during solar eclipses with the telescope. And one of the most perplexing things is that it is actually hotter than the surface, and we realistically don't have a clue why. I mean, there's always ideas in science. I don't think I have to tell your audience that anymore. I always preface everything I say with there's some ideas. There's always some ideas, some theories, some which are probably much better than others. But realistically, I mean, this is a puzzle. Why is the corona so much hotter than the surface?
So what's your speculation as to that?
Oh, I have no idea.
No,
I have no idea.
Well,
yeah.
If you have no idea, I have no idea whatsoever. Yeah. I do think
I'm not a solar astronomer type of guy. I don't care much about ordinary stars. You know
that I'm a bit weird. I'm a bit out there, and I like to kind of explore the electrical nature of the universe as well. Uh-huh. Perhaps maybe the answer lies there. Maybe it's not quite as anomalous as we think if you start to introduce more of the electric universe ideas
if
into the
if
equation.
someone could come along and put together a framework and make predictions with it, and they could predict that the temperature of the sun's corona should be, the temperature that it is, and the temperature of the sun's surface should be this temperature that it is, and they could push that into the scientific literature, I think it would be well received.
It's good.
I don't think they would be boxed out at all.
I think you would enjoy looking at some of the people that work on this, because it's not people like me. It is astrophysicists. It is people from mainstream science, and what they're able to do a lot of the time, Brendan, and this is what really gets me. Some of the things that we do see in space, when you start talking about plasma and electrical currents and things, you can nearly or as good as start to replicate some of the effects that we see out in the cosmos in the laboratory with plasma. Now, again, you'd need to look into it yourself, but it's this Thunderbolts project. It's somebody, I think his name is Kip Thornhill. I think that's one of them. Probably got that guy's name wrong, but the Thunderbolts project, I think it's thunderbolts.info. Really, really interesting stuff. And again, I'm not saying that they have got all the answers to everything in the cosmos, but I think, maybe when you come at it this way, and I like how you said that, it doesn't make sense. It doesn't make sense that corona should be hotter than the surface, right? Unless there's something that we're not taking into account. And it might not be anything to do with the electrical universe. It might just be a variable, something that we just haven't considered,
Yeah, it is likely due to the magnetic field of the sun, I think, is where most of the prevailing ideas lie, in that it has something to do with the sun's very strong magnetic field, but not qualified to speak on that exact topic. So,
and I'm barely qualified to speak on anything. So
the thing is, though, Kev, this is interesting, though. You're more qualified than me, and here's why: you have less of a blowback if you say something wrong.
Well,
right?
Yeah. No, I totally appreciate that.
If I say something wrong, then I have, for example, you could look at that Twitter post I had. You'll see people in the comments, scientists, saying, whoa, did you consider this? Did you consider that? Did you consider this? That happens every time I post about science, because we all will want to check everyone else. We want to make sure everyone else is doing what they say they're doing and doing it correctly. And sometimes that can be taken a little far. And if you get the wrong people doing it, then it could be misinterpreted as them being an asshole. And in some cases, they are being an asshole. Listen, every field is full of nice people and full of bitches, okay? And sometimes, unfortunately, you have some inquiring mind who comes in contact with someone who's just not good at communicating things, not good at talking to other people. And sometimes that person happens to be a scientist. And when that person happens to be a scientist, then you have someone who now doubts the entire field of science. So the goal is to avoid those types of people, but you can't avoid those types of people always. There's always going to be people critiquing your work well beyond any measurable point of critique. For example, if I post a silly video on Twitter, which shows the way that the sun would look from the Earth, I'm clearly not trying to do respectable, publishable science. That's not the goal.
No.
Okay? In fact, there's these funny cartoons made that are like, how technical are you supposed to be when you communicate science to people who don't necessarily know science? And my answer is you're not supposed to be very technical at all. Because if you're super technical, no one's listening. If you're not, if you're really, really, really loose, then there might be a ton of people listening, but they're all going to get nonsensical information. So you have to find that sweet spot where you're saying enough technical information, right? But you're not making it so dense that people say, listen, Brendan, I don't care, dude. I don't care about swirling plasmas and electromagnetic waves, and I just don't give a shit. So you have to find that nice medium ground. And some scientists have no idea where that medium ground is. And thankfully, those scientists aren't the people that do the outreach. The people that do the outreach are most likely the people who are going to find that middle ground and be able to speak to people and have people be receptive to them, and not the people. Listen, man, I've been in this field long enough to have met some people who just should not be talking to other non-scientists. They just shouldn't. They should just stay in their bubble. They should talk to the people that they talk to every day, and they should probably not even talk to their family because they're just terrible at speaking words. And those people exist in every field.
I've interviewed some of those people.
Yeah.
No, but listen,
Yeah.
you and Brian Keating, I can't speak highly enough about the two of you because, the last segment of radio there, we went away on a tangent. We spoke about this and that, and you're able to do that, and so is Brian. A few scientists I've come across, they can only talk about the thing that they know, their chosen field. And like you say, it's almost as if they try to throw in all the technical jargon just to prove to themselves and everybody listening that they're so important. But while they're doing that, nobody's understanding what the hell they're talking about, Right.
And some of it can be that. Some of it can be nerves. Some of it can be, some people might do a great job of explaining something if they can sit down at a computer by themselves and record a video and do 100 takes and, make sure all the audio and everything is pristine. And some people might be able to do a fantastic job of doing that. I'm sure there's people on YouTube who make astronomy or physics videos, and you would be surprised at how many times that they record before they upload. And then there's some people who don't work well in that environment and they're best speaking freely. And when you mix those two, when someone gets confused about their role or what they're best at, then you don't get a great product. So I personally don't think I do well if I meticulously think out every word I'm going to say. And I do the same thing when I give public talks or public lectures about my own work. Like I cannot, if I over prepare, then the talk is not going to be good. It's going to be much better if I can improvise and almost in a way read the room, like understand what are people feeling? Are they bored? Are they happy? Are they thinking? Do they think it's too funny? Do they think it's not professional? And adapt on the move. And everyone's different, but people need to know where they lie and analyze themselves and assess themselves. There's aspects of things I'm not good at, right? And even like in this format, there's things that I'm not great at. And so you got to constantly improve and get better and try again and keep going. And my comments before were not trying to say that if you are one of those people, then you should never do outreach. That's not the idea at all. The idea is identify what outreach you do best, identify how you communicate with people best, and try to stick to doing that thing or make an active role of getting better at the other things.
Very well said, and there's not much you don't do well when you come on the show, I must admit, Brendan. So I wouldn't be too self-critical or hard on
NASA
yourself.
tells me I do a great job of shilling. When
we come back after the break, I was saving it for last. We're going to really get into our NASA shilling mode. They've been coming up with new missions, things like that, so we'll be taking a look at all of that. But what you were talking about there, I mean, when it comes to me doing the show here, I very rarely prepare, and you're the perfect example of what goes into a show, because I think you roll like me. You send me a few articles that we can have pulled up, a few topics to get into, but you never tell me, well, Kev, we're going to just touch on this and we're not going to get into that. We just have a natural conversation about the topics that you bring along, and I think that is probably appreciated by the audience more than one of these very kind of structured question and answer, and it would just get boring, dude.
Exactly. And I try to structure my own show in exactly the same way, where I say, okay, I try to give my guests a ton of information. Like, here's all the things I want to cover. Here's even some of the concepts I want to cover. I never give them a question. I never say, Kev, I will ask you this question. I don't think that's good. No. I think if you do that, you're going to have a conversation that just seems like so scripted and choreographed. It's going to be odd, because then the person is going to game plan for that question. You're going to ask the question, why is the sun's corona so hot? Why is the sun's surface not? And if I gave someone that question beforehand, what they would do is they would go out and they would come up with a page of details, and they would rehearse that page of details. Here's the ideas. Here's the concepts. Here's the theories. Here's why. Here's how we're going to learn more about it. And that would be a fantastic way to make a YouTube video called why is the sun's corona so hot? And if you wanted to do 8 minutes of just going over all of the information, perfect. But I don't think that works well in a conversational format. It's not made for this. And so I never give them a question, because if you give them a question, they prepare for the questions. And then when you go off script and you ask them a question that's not on that list of questions, then they get baffled, and rightfully so, because they don't expect you to do it. So yeah, I'm always very straightforward with people. I'm like, listen, man, it's a conversation. Here's the topics I'm going to get to. And I'm very rigid about the topics. Like, we're going to do this topic, we're going to do that topic, we're going to do that topic. Maybe not in the order I gave them to you, but we're going to try to get to them all. We're going to talk about them all, and that's the goal. And in between, we're going to talk about wokeness. We're going to talk about religion. We're going to talk about sex. We're going to talk about academia. We're going to talk about everything.
We were even talking about the Patriots before we came on air today. I was telling Brendan I'd watched a good documentary about Aaron Hernandez. I had no idea about that young man, his life story, but wow. I remember you sharing with me last time you'd been at the playoffs, the Patriots, so I was thinking of you watching that, and what a tragic story. For anyone out there, you know, if you like documentaries and things, I'd give that a look. It's 3 parts. Hell of a story, Brendan, you know.
Yeah, have you? It's a crazy story.
Yeah,
It's
I
didn't watch the documentary yet, and I imagine they do some good investigative journalism. Netflix always pretty good at that.
Yeah.
Although they tend to make way more episodes than they need to.
It's just, you
Like,
know, I came away from it, you know, you get, so often we have this image of what people are because of their public persona or their celebrity and their fame, but they're real people in the end of the day. They got real problems, real hurt going on, and away from the lights, away from the glamour and things. I tell you, dude, it's really powerful documentary.
Yeah, have you watched Don't F with Cats?
I
can't
haven't
say
watched
the
that
word
one
on your
yet,
show.
but it's on my list. Only, if nothing else, for the title of it, you know?
It's got to be number 1 on your list.
Oh.
It has to be the very next thing you
without
watch.
giving away any spoilers, this is where literally there was somebody being bad to cats online, and people took it upon themselves to track them down, right?
Yes. Do you know spoilers though? Like, have you heard about the show?
No, I haven't. Now, we're
Okay,
going on the
keep
break.
it that way.
Yeah, we're going on the break. I'm now going to write that down. I'm going to watch this after the show. But we'll be back. One more segment to go, and I promise we'll get back into space. NASA shilling on the way. Don't go anywhere, folks. There we go. One segment to go, Brendan. Yes, I like how our shows usually break out into other topics. We branch off, and then we come back. We've got that core kind of topics that we come back to. And after the break, obviously, we'll get to NASA. I see your little patch proudly behind you there.
Yep.
Triggering people everywhere across YouTube. But quite exciting stuff coming up with NASA. But that Don't F with the Cats. So you recommend that one then, yeah?
That documentary, Kev, is insane. Insanity. I don't know how. Somehow I didn't hear about it while it was happening, because it happened in like 2010 or so, 2012. I don't know. Sometime when I was old enough to know and somehow didn't. It's insanity. You need to watch it.
I had no idea of the actual story that it was like centered around. I had no idea until I seen a trailer for the actual documentary, you know.
And there's 3 episodes, and it just progressively gets more insane to a point where you don't think it can be as insane. When you hear about a dude that's torturing cats, you think like, whatever. I don't, that could be fun, but that's not on the top of the list. It gets crazy to a point that, like, I don't want to spoil it for you.
No, I know you won't.
But it gets crazy.
Yeah, sounds good. But I tell you, I must admit, it's probably going to trigger me. I'm a big cat lover. I've got my cat lying behind me, sleeping away.
I was eating lunch when I first watched it, and they started showing a video of a cat being killed. Thankfully, they don't show anything gruesome. They don't show anything gruesome. But I had to turn it off and come back to it later because I was eating. I'm like, I can't watch a cat.
What is it about humans, dude, that we tend to almost care more about animals than we do about each other? It's an observation that many people have made. You know, you hear about, like the Australian fires, we spoke about this, you know. People absolutely heartbroken, rightly so, about the amount of animals and wildlife. Yet those actual people lost their lives as well, and nobody was talking about it.
It might be the same instinct that leads to wokeness. Is you want to stick up for things, and and people that you feel can't stick up for
You want
themselves.
to be that white knight. You want to ride in there and save all those helpless animals.
Yes.
Yeah.
And you know, the blue-haired lesbian at, you know, a university in New York wants to ride in there and save all the underprivileged people.
Yeah. Yeah.
So yeah.
Crazy world, man. Now, like I say, when we come back after the break, folks, we'll be getting into NASA. And tomorrow on the show, I've got Ryan Gable is coming on. We might have a few people calling in throughout the show, though, as well, with it being the 6th anniversary of the Kev Baker Show. I have mentioned that today, yes. So it'll be not quite as structured or as typical a show as we usually do with Ryan, but I really hope all of you can be here for that tomorrow night. I'm looking forward to it. It's kind of a landmark, I think we can all agree. And I hope all of you are here with me as well to celebrate 6 years on the network. And I keep on looking at the clock here. We're nearly going back. I can't believe we've only got one segment to go with Brendan. It always goes quickly, my friend, but tonight it's gone double quick. Probably because you managed to take me into all that wokeness that I just absolutely love to talk about, Brendan.
Yeah. No, I love to talk about it too.
I do, but I end up usually getting angry. And Joe, one of the guys I do the show with, he purposely tries to trigger me into it. He's bad that way. Here we go. Welcome back. Final segment on today's Kev Baker Show. And don't forget, tomorrow, the show turns 6 years old. Not me, personally. Some of you might think I've got the maturity of a 6-year-old. At times, I would have to agree. But yeah, 6 years on the network. Speaking to so many amazing people along the way. And today, another amazing person. Somebody that comes on once a month. And he's our little scientist. I dropped the mainstream. He's Brendan Drachler. And remember, check out his website, thestateoftheuniverse.com. So, NASA. We often trigger people with our desire, how would you put it? Just talking about NASA triggers people, dude. So what's been happening? Because they're coming up with a whole new set of missions, right?
Yeah, so I think it's every budget cycle or every few years. I'm not sure when they decide. Maybe every 5 years. They come up with what they call a discovery mission. Let me turn my brightness down on my computer. It's blinding me. They come up with what they call a discovery mission. And a discovery mission is essentially exactly what it sounds. It's a mission which is not necessarily aimed at, you know, changing the view of the universe. Like, okay, a mission to Europa to drill into the ice is not a discovery mission. Okay, that's a mission that's undoubtedly going to lead to some like crazy, fruitful, amazing science. A discovery mission is more or less a project that doesn't get funded at the level of some of those major missions, but and will explore some we'll use the woke word, underprivileged communities in the solar system, and try to answer some interesting questions about them. So the options, they've narrowed it down to 4 that they're going to choose from and fund one of these. Of the 4, 2 of them go to Venus, one of them goes to Io, and one of them goes to Triton. And Io is the innermost Galilean moon of Jupiter. Triton is a moon of Neptune. And it's what's really interesting to me is that 2 of the missions are proposed to go to Venus, because there's been this renewed interest in going back to Venus, like a really renewed interest. And part of me kind of blames climate change, because Venus is our sister planet. I mean, in terms of the parameters of the actual planets, they're very similar, the Earth and Venus, very similar. Venus is obviously a very, very hot place with a very dense atmosphere, and it orbits much closer to the sun. The Earth has a moon. Other than those differences, they're very similar.
So what's the one that excites you the most then, Brendan? Because I know if we were launching a mission, it would be to Titan, but out of this 4, I mean, what do you think?
I think that the most interesting, okay, so we already have the Europa Clipper mission happening. So the Europa Clipper will fly by Europa. It will answer some of the long-standing questions like, is there, in fact, a liquid ocean underneath the surface? You know, it will answer questions like that. So that side of me is fulfilled. So with that in mind, the place that interests me the most next, after like cool places like, getting people on Mars, going to Europa, going to Titan, things like that. The one that interests me most is probably one of the Venus missions. Okay, and the Venus mission is called, I'll have to pull it up, Da Vinci Plus. Stands for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging Plus. Okay, I don't know why they had the plus there. Whatever, they just wanted to. The point though is this excites me because this will actually aim to go into the atmosphere of Venus with incredibly upgraded technology. So I don't know if you remember, Kev, from your childhood. How old are you these days? 70 or so?
Near enough. I feel it, dude.
So if you remember though, you're probably incredibly young. We actually have sent missions to Venus, and we've actually landed on Venus with rovers. They didn't last long. The reason they didn't last long is because, number one, it's incredibly hot. The atmosphere is incredibly volatile. And the thing that wasn't necessarily completely accounted for is the pressure. Yeah. So the pressure on the surface of Venus is about 90 times greater than the pressure on the surface of the Earth. So if you could put a robot there and it's going to be crushed just by the atmosphere. It's just going to be crushed. And so our most successful rover, I think, was actually a Russian rover, and it lasted 90 minutes, 93 minutes, something like that, before it died. Now we will game plan for that. We will be able to send, really high tech, advanced technology. And the goal is not to send a rover. We're not going to be roving, but we will be plunging into the atmosphere and taking very, very high resolution pictures and trying to answer questions about, number one, did Venus used to have water? Okay. How number two, what's volcanism like on Venus? What are the minerals like on Venus? What are the mountainous regions like on Venus? What is the surface of Venus like? What is the atmosphere of Venus like? All of these important questions to help us understand what happened to Venus. Did it used to be a normal planet? Did it used to be just like the Earth? Did it used to have water? Did it used to have an atmosphere? And then something catastrophic happened? Because one of the most interesting things about Venus is it spins backwards compared to all the other planets. But not only does it spin backwards, it spins so incredibly slowly backwards, which implies to a lot of planetary scientists that it was hit by something major. Like it really got clobbered by something. So much so that it took enough angular momentum away to make it spin the other way and to slow it down to essentially to the point where it's not moving. So
now, is it Venus or is it Mercury that's really, really dense in its core?
Is it Mercury or Venus? I'm not sure about the core density. I was watching
a documentary today, and it's just when you saying there about something possibly hitting Venus, and it was talking about the early solar system and how it was really kind of catastrophic. It was wild, and that's when we got the rings around Saturn. It was explaining how that was potentially an ice moon, and the core of that went into the planet, and all the ice got stripped off and made into the rings, and it just makes you think back to that early solar system, dude, and the fact that we ever made it here in the first place, this planet Earth, all of the things that came together for us to be where we are right now, how that can't blow people's mind is beyond me.
No, it's incredible. And sorry if you hear some helicopters, Kev. I think the Black Hawks are outside
helicopters,
again.
Man? Are they coming for you? Oh, cool, dude.
Yes.
I've never had a guest taken away by SWAT team or anything. That'd be awesome.
Yeah, hopefully that doesn't happen right now.
You see, this is what happens when you speak badly about the safe space on the campus there. Somebody has literally swatted you, dude. They're going to come in through the window in a minute.
That would actually be crazy if that actually happened. If someone in your chat swatted me.
It wouldn't be our chat. It wouldn't be our chat. It'd be one of those safe space people in the university there. We don't have the SJW type following the Kev Baker show.
Yeah. Well, you always have a few. They're hiding. They're pretending.
Are they lurking?
They're in there. They're in the chat. So? They're looking. They're watching. They're clipping everything they can.
Getting triggered along the way.
They already have a clip of me saying transgender people are worse than neo-Nazis. They already have that. They already have a bunch of other stuff.
Surely not.
They take out a few words in between other words to make it sound as worse as possible. Yeah, no, I know they're there. Anyway, what were we talking about?
Yeah, well, I was talking about the early solar system, things crashing, and who knows what it was like,
Just type in composition of Venus in Google, and we can answer your question very quickly. So I'm fairly sure that the composition of Venus is similar. We suspect it's similar enough to the Earth. So if you go ahead and click on, you could just go to yeah, sure, go to images.
Fact,
This
yeah, just go to
website seems
images, yeah.
useless.
You see, that one there looks like an ordinary core. So I would say it's Mercury then.
Yeah, I'm not sure.
Because
Could be either.
they were showing how potentially it had this dense core because at one time it was bigger, only something smashed into it and ripped off a lot of the outer casing, for lack of a better term, you know.
My intuition is telling me Venus has an abnormally large iron core compared to the Earth.
Yeah.
But I might be wrong about that.
It's one of those two anyway.
Yeah, but yeah. Anyway, we'll answer. We need to answer those questions because we don't necessarily have good answers to them. So what is the composition of Venus exactly is something that we don't actually have pinned down. So that this mission will aim to answer that. The other Venus mission is interesting because they actually propose to put. I think that this is the Venus mission that I was reading about, unless there were more than 2 Venus missions proposed. But I'm pretty sure that they proposed to put. Hot air balloons in the upper atmosphere of Venus to study the atmosphere for long periods of time rather than just plunging through them. So that's an interesting prospect too.
Is this the Da Vinci one? The
I believe so.
Atmosphere Venus Investigation of Noble Gases, Chemistry
Yes.
and Imaging Plus.
No, that's Da Vinci Plus. So that is the one I was just talking about. And then if you scroll down, they should have the other one.
Veritas.
Keep scrolling. Yeah, there we go. So this might be a radio. This might be a mission that's meant to map the surface. So the mission I'm talking about might have actually gotten killed.
Oh,
yeah,
we want your mission. Your mission sounded better, dude.
Yeah, any scientist, any person actually, any U.S. citizen can assemble a team of scientists, researchers, engineers, and propose one of these ideas and say, hey, we want to go to wherever. We can do it in this amount of money, and then they can potentially get accepted. So some of the coolest missions in the history of science have been some of these missions. So as an example, Kepler, the Kepler Space Telescope, which discovered, like 4,000 exoplanets, something like that. That was one of these discovery missions. So these missions can either be things you just never hear about. They don't find much, and that's fine because NASA's not investing much into them, or they can be something that changes the way we look at the universe. So no, this is an interesting thing that in the next decade we'll see one of these come to fruition. The one to Io will be really interesting too, because I don't know if you know much about Io. Kev.
I don't.
Okay, so go ahead and just type in Io Jupiter. Literally Io. Yep. And this is the most volcanically active body in the entire solar system. So if you go to images, you can see some of these awesome images. You can see all of these. There's so many volcanically active regions on the surface of this moon. And the reason is that it's so close to Jupiter. So it's incredibly close to Jupiter. And it's literally, the core of the moon is literally being tugged on, like jello, just being tugged on by the gravitational pull of Jupiter, by the tidal forces of Jupiter. And it's causing the inside of the planet to heat up and just explode in incredibly volcanic activity.
So,
and we don't
so
understand.
not like Yellowstone then. I know you're going to be speaking to somebody from Yellowstone too. This is what we don't want to see Yellowstone doing, right?
That's correct. Yeah. We don't want Yellowstone to turn into our own mini Io. That would be bad.
How many moons has Jupiter got roughly? I mean, do we know exactly how many?
My guess would be 67. You could look it up. There's many. Of the meaningful ones, there's probably only 4. You can change the definition of meaningful, but the Galilean moons are the ones that are sort of respected as the important ones. But there's many moons of Jupiter. Let's see what the number is.
79 confirmed moons.
Oh yeah, and that number goes up. So constantly that number is increasing. It's sometimes tough to find new ones, and we find more.
Let's go to NASA. We'll give NASA the official word on this since we shill for this brilliant organization. Yeah. Jupiter is 53 named moons and another 26 awaiting official names. Well, they might choose to be identified as something other than a moon.
They could, yeah.
Exactly, yeah.
Yep.
Yeah.
That's possible.
I need to keep
that's
an open mind on that one.
that's the holdup, Kev, is we have to make sure there's no life on them, so that way we can get their pronoun right. If there is, we can ask them and say, do you want to be a moon? Do you want to be a minor planet? Do you want to be a satellite? We can call you a satellite. We need to make sure we get that right.
Yeah, we have to get it right because we don't want to hurt the feelings of one of these planetary bodies out there.
That's right. I think Saturn has more. You could type a number of moons surrounding Saturn. I think Saturn has even more than 79. Yeah, these large planets on the outskirts of the solar system, they tend to attract, because they're so large, they tend to attract all the objects around them. And so they have tons and tons of moons. Now, they're all not huge, right? A lot of these moons are pretty small and meaningless, but nevertheless, they have a ton. So moons of Saturn, that Wikipedia page will probably give you some number, or this will give you a nice number.
We need to go to NASA, they're the authority.
That's
Come on
true.
now. Saturn has 82 moons. 53 of them are confirmed and know what gender they are. And another 29 of them are still kind of in between. They're not too sure what it's going to be. And it says Saturn's moons range in size from larger than the planet Mercury, the giant moon Titan, to the small as the sports arena. So you're talking about things not much bigger than, obviously bigger than our traditional satellites we launch into space, but the size of a sports field, that's it. That makes a moon.
Yeah, see, this is one of the weird things about the designation of the word moon, because if you were to put something the size of let's say, I don't know, Gillette, what's a famous arena, like the O2 arena maybe?
Yeah.
If you were to put something the size of that around the Earth, we would call that a moon. In comparison to the size of our own moon, I mean, it's not meaningfully big, but it's big enough that we would probably send something there to explore it. We would call it a moon. It's a rocky body orbiting around the Earth. We would call it a moon. Now, do you call it a moon when it's around Saturn? That's the question. And so I don't know if there exists a good designation for what is and what isn't a moon, because in rough terms, the word moon has been kind of corrupted, right? Because when we say moon, we think of our own moon. That's why we tend to call them satellites. So the proper way to phrase the question would be, how many satellites does Saturn have? Again, you got to ask what they want, but that's how I would say it. But the word moon makes it feel important. Like when you say the Earth has a moon, it feels important. It's like, we have one moon. It's an important moon. We want to go there. We want to explore. We want to do all this stuff. It's important. Has an important connotation. It means something. The moon has helped us survive, thrive, be alive, and even begin to be alive. So when we go other places and we look at a moon like that one, then we get the idea that, wait a minute, this can't be a moon. Moon means something important. This thing clearly isn't important. So generally we call them satellites to get rid of that important connotation. But yeah, what is and what isn't a satellite is a good question.
Is it strange or anomalous that we only have one moon as opposed to 60, 70, 80 that we're reading about with these other planets?
No, there's actually something super interesting. There's nothing. No. There's nothing important about it.
I'm not looking for some conspiracy or anything. Just maybe like compared to planets we know, it is a bit strange or something.
No, there's nothing important about having one, but there is something important about how big it is. The moon is big, and it's a big question about how this system formed. We don't know that yet, and we won't know that until we can go to the moon and do real good science, like real good science in the sense of digging beneath the surface, learning about the composition of the moon, learning about what makes up the moon, because what we want to try to answer the questions, are the moon and Earth made of the exact same things? And if they're made of the exact same things, maybe they have a common ancestor. Maybe they were created by some collision, maybe something like that. But no, the fact that the moon is so big is so interesting. There's actually this really interesting historical wooey thing that I think you'll get a kick out of.
Yes, indeed.
There was a time in the history where we didn't know Mercury existed. Okay, we didn't yet observe Mercury, and we observed Venus, and we knew Venus didn't have a moon, and we knew the Earth had one moon, and we knew Mars had two moons. Okay, we're talking about hundreds of years ago. And we observed Venus, or Jupiter rather, and we knew it had four moons because we could only see the Galilean moons. You can't see any other moons than the big four unless you have really good telescopes. And so it led us to a lengthy search for a planet in between Mars and Jupiter. And we were looking for a planet, and we were sure, I shouldn't say we, because there's probably hundreds of astronomers who didn't think this at all, but some people were sure that there would be a moon in between those two, and it would have 3 moons, or a planet in between those two and have 3 moons. And this is an interesting way in which, sort of human intuition, because if you see that, if you say, okay, we know Venus is closer to the sun, it has 0, we know we have 1, we know Mars has 2, we know Jupiter has 4. So it only makes sense.
It's a logical assumption to make.
Yeah, it only makes sense that every planet outward you go, you get 1 more moon. So therefore there has to be one in the middle, and it has to have 3 moons. And so people searched for it for a long time. In fact, it was these searches that led to us discovering many of the bodies in the asteroid belt. And we're looking for this missing planet that isn't there, and it doesn't have 3 moons. And now we know Jupiter has whatever the number, 69, did you say, or 79 moons? And
Saturn
Mars,
has 82. 82.
Saturn has 82. Jupiter has 79, or whatever number we just figured out. So yeah, we know that's nonsense. But there was a period of time when people thought that.
Well, it's even that documentary I was talking to you about today. I think it was. You would know the personality, the scientist, if you were to see him. If I could remember his name, he's really famous. But he was also talking about this tumultuous time in the early solar system, where the potential for even a planet to get ejected out from the solar system, that may have occurred at some stage during that. It was talking about Uranus and Neptune swapping orbits and things like this. And it does, it makes you wonder then, if there was, at some point, an extra planet, if there was something different there.
Yeah, I mean, there are people still to this day, I think, trying to understand anomalies in the orbits of some planets. So anomalies in the orbit of Pluto, say. And this has led to, or anomalies in the orbits of comets even, and led to many people saying there has to be a massive planet outside of Pluto, a massive one, a big one, not one that's the same size of Pluto, not one that's slightly smaller than Pluto. There has to be a massive planet out there. Can we find it? Where is it? And this is happening decades ago, and it's happening now. There are people who think there's probably some missing mass in the solar system, and it's out there somewhere. Now, it's really hard to find. It's really hard to find a planet that is moving that far away from the sun. I mean, it's dark. It's not going to emit much light. It's not going to emit anything that really will allow you to see it well. It's not going to shine like a star. So it's hard to find.
Apart from it affecting the orbits of comets or something that we know about, then it's nigh on impossible to find.
So generally when we're talking about objects like this, we actually discover them by accident. And the way we discover them by accident is we'll have a telescope just doing its job, looking at a field of stars somewhere, just looking ordinarily at a field of stars. And then we'll notice something. We'll notice that some object came into our field of view and is moving much too quickly to be far away. Because you could look at a star far away, and Kev, you know that star is going around the center of the Milky Way. It's moving. Not only is it moving, but it's probably moving pretty fast. But because it's so far away, it looks like it's standing still. It's the same thing when you're in an airplane and you're looking down at a highway. The cars are moving. You know they're moving. They're doing 70 miles per hour, 80 miles per hour, but they don't look like they're moving. They look like they're standing still. And it's the same idea with stars. We look at stars. We don't have to necessarily account for the fact that they're moving. When you go outside at night and you look at a star, it's not going to zip out of your field of view. It's going to pretty much stay where it is. Planets, on the other hand, won't do that in your telescope. Planets will actually move a considerable amount as you look at them. And so we found several planets in this way, several objects in this way, as we were out looking at stars, looking at whatever we wanted to look at, and then something came in our field of view and it was moving too fast. And then we track it and we say, whoa, this is something interesting. Let's learn about this thing.
And I remember it was Caltech. I don't know if they're still looking for that. Planet 9, I think they were calling it at some point.
Yes.
I know there was a lot of buzz about it, but it kind of went quiet, all that talk. So I take it they never found what they were looking for.
Yeah, I know exactly what you're talking about. And I don't know actually the progress on that idea.
I would imagine we would hear it if there was anything major to report, because even the suggestion at the start that there might be something there, it got world attention. It went everywhere, went viral, and rightly so.
Exactly. So I remember their paper, and their paper didn't claim that they found something. Instead, what their papers claimed is that they can track the orbits of all the planets, and they can come up with an approximate mass of what a planet should be, a planet 9 should be, if it were outside the orbit of Pluto, and how massive it should be to account for the anomalies that they're seeing. And they came up with a pretty large mass. I don't remember the mass they came up with, but they came up with an appreciable mass. And I don't know if that idea has been corrected. Maybe our observations of planetary orbits were bad, because that's true. Like, you know, sometimes it's hard to track planetary orbits like that of Pluto or some of the massive objects further out. It's hard to track some of them. Because
and what is Pluto now? It's a bit woke. It doesn't know if it's a planet, if it's just hanging about out there. You know?
It's up in the air, but it's a cool place. That's for sure. New Horizons proved to us that Pluto is an awesome place.
I was quite disappointed when they ruled that out from being a planet, to be honest with you, because growing up, Pluto, you know, when you're a kid and things, that furthest one out, and I don't know, there's something about it. I was a bit kind of miffed when they took away its planetary status, and then some people give it back to it, some people don't. Like I say, it's all getting a bit woke, even in space. What the hell's happening? Brendan,
the problem is,
we're almost out of time, dude. Finish it up. We're almost out of time. The problem is...
I was going to say that there's more planets further out, or minor planets, that are like Pluto, almost the same size as Pluto. So you had a sort of conundrum. Are you going to call everything a planet, or are you going to kick Pluto out? And they kicked Pluto out.
Shocking. Give us back our Pluto. But Brendan, this has been awesome. Let people know where they can follow your work and anything else you need them to know before I let you get back about your business, back to the safe space, right?
thestateoftheuniverse.com. Find us on YouTube, Apple Podcasts, Stitcher, Google Play, Spotify, wherever you listen to audio. We got the audio up on YouTube. We got everything everywhere. Thestateoftheuniverse.com. Subscribe to the Patreon. Rate the show 5 stars on Apple Podcasts if you have an iTunes account. It helps shows so much that people don't realize it. So much. Kev, I can go from being the 15th show in the United States for science to being the number 3 just with one extra review. So
give them a star. Give them a star, folks.
It factors into the algorithm so much. Go do it.
Absolutely. And folks, want to thank all of you for tuning in once again. Don't go anywhere after the break. We've got Dr. Brooks Agnew and Lucky on the way with Quantum Connections. I'll be back tomorrow on the 6th birthday of the Kev Baker Show here in the network. And I'll be on YouTube earlier on in the day with, I think, a very, very special friend of myself and the show. Keep an eye open for that. Until next time, wherever you are, make it TFR and dinny touch that dial. There we go. Now, we're still on YouTube right now. I know my friend Nano Girl has been messaging me. Nano is going to join me tomorrow, folks, on the earlier stream during the day. Watch the YouTube channel. I'll be putting a link up for that in the next hour or so. But I would imagine it'll be about 6 p.m., 7 p.m.-ish in the UK. And then, of course, I'll be back for the main show tomorrow night with Ryan Gable. We'll be getting into a whole host of things. Hopefully, I'll be getting in touch with Charlie Robinson during the show. Find out how everything went down at Anarchapulco. I've seen him taking pictures of Ron Paul on the stage, showing off, so he was. Posting them all over social media. I'll need to be having a word with him about that. But please join me tomorrow for what is going to be a really, really good show. It's going to be a lot of fun. We're not going to answer all of the biggest questions in the universe tomorrow, that's for sure. Probably not going to break any news that you haven't heard anywhere else either. But when Ryan Gable comes on the show, you know that it's always, always brilliant information. So a big thank you to Brendan again for his time. And I'll get you after we play some crazy little tunes for 30 seconds, Brendan. We'll let the stream catch up. And thank you again, brother, for your time. And anytime you come on, don't you worry about going into topics that aren't on our list. I love exploring these cultural topics that we sometimes get into.
I never worry. I never worry,
man.
Kev.
Good man. So, folks, until tomorrow, keep it real. And like I like to play us out with now, keep your mind open. Keep looking for the woo, but not to the point where your brain turns to black goo.